Hello and welcome to another video. In this video we're going to be working on find if array can be sorted. And in this one you're given an array of positive integers nums, and in one operation you can swap any two adjacent elements if they have the same number of set bits. You're allowed to do this operation any number of times, including 0. Return true if you can sort the array. So just quickly talking about set bits. Set bits just means like the number of bits in the number in the binary representation. So for example, like the number 5 has like this. So this would be 2 set bits, and so on. And so the number 30 is like a 16, an 8, that's 24, and I think it's like this 30. So essentially, basically, break it down your number into binary and get the number of bits. And that's like an easy problem, so I'm going to assume you know how to do that. So basically, take a number, get the number of bits, and then see if you can sort them. So in this example, so 1 has 1 bit, 2 has 1 bit, this is 1 bit, this is 1, actually, 3 has 2 bits. This has 1 and this has 2, but it's already sorted, so you don't need to move anything. So like number of bits doesn't matter because you don't need to move anything. In this example, this is 1 bit, 1 bit, 1 bit. I think this is like 5, right? 16, 8, 4, 2, at 4, I guess. And then 15 is no 16, 8, 4, 2, 1. So this is 4 as well. So you can sort here because basically you can move these around, and then you can move these around, right? So you can do a swap where like 2 will swap with 4, will swap over here. But the main idea is like whenever you have a group that has the same number, you can swap those. But whenever there's a difference, you can't swap those. So you can kind of split your numbers into groups. So this is like a group, another group. And then you can just see like, can I sort the group? And yeah, so this group you can sort right into 2, 4, 8. In this group, you can sort like this. So like that's kind of the big picture idea. And then this one, so this has 2 bits, 1, 1, 1, 1. And you can't sort this because 3 needs to be the second element, but you can't, like 3 is in its own group, so you can't move elements from one group to another. So there's kind of 2 ways of doing this, and one is more intuitive and one is less intuitive. And the more intuitive way is a bubble sort, because in a bubble sort, you're basically swapping adjacent elements, and here you are able to swap adjacent elements. So it's like, what sort do I know that I swap adjacent elements? And it's basically a bubble. So here, you would just say like, okay, like let's say, I'm just going to color code a bunch of numbers representing with how many set bits they have, right? So let's say this is like one group where I have like 3, 5, and then here's another group of like 1, 4, yeah, something like that, let's say. Like this is my numbers. And basically in a bubble sort, it's pretty simple. You just start at the first number, and you keep comparing the current number you're at to the one after, and if you need to swap, then swap. And you can just check if they have the same number of set bits or not. And if you need to swap and they don't have the same number of set bits, then it's unsortable. So like here, you'd start here and you'd say like, do I need to swap? No, this is in order. And then I'm gonna check here. Do I need to swap? Yes. But I can't swap because these don't have the same number of set bits. So basically, whenever you need to swap in a bubble sort and you can't, you would just return false. And otherwise, you would just do like the main bubble sort and then you're done. So that's kind of the idea. And bubble sort's pretty simple. Like I said, basically nested for loop n squared. And this is only 100 elements, that's fine. Yeah, so, if this was in another way, if this was like, 3, 1, or something, and then this was 5, 4, then you would be able to do this, right? Because basically what would happen is you'd be like, okay, well, the 3 and the 1 need to swap. 3 and the 1 need to swap, so I'll do that. Then you go to the next element. These don't need to swap. These do need to swap, so I'll do that. And then you start again at the second element now, and you say like, these don't need to swap, these don't need to swap, and then you're basically done. I think you can cut the bubble sort short too, as long as you need to swap anything. There's basically like a bunch of different sorts you can do. I think the even simpler version of this algorithm is just always start at the start and go to the end and keep swapping, and then whenever you didn't need to do any swaps, then return. I think that's also kind of like a bubble sort. It's something like that, but basically it's n squared. And so that's one way. The less intuitive way is split your numbers up into groups and realize, okay, I can't take numbers from one group and swap with another. But what I can do is for every group, I can maintain a min and max. And so basically what you're going to have is you're going to have a min and max. So let's say for this example, you'll have a 1 and a 3. This is group 1. This is group 2. So you'll have like a bunch of intervals, essentially. And then all you need to do is just check, do my intervals overlap? So the max of the group before has to be smaller than or equal to the min of this group, and so on. Right? So if I had another interval here, that was like 1, 6. Because I can't swap from different groups, this could not be sorted because this 5 is bigger than this 1. So this can never, like this 1 can never get where it needs to be, essentially. It can't move. So that's kind of the idea. You just have groups, and then you just compare, like, do they overlap? And the way to make the groups is also pretty simple. But it's kind of hard to come up with this, but once you understand it, the way to make groups is really simple. So these elements will have the like, number of set bits. This will be like one number. Actually, the way I drew this, these technically wouldn't have the same number of set bits, but let's say they did. Like, let's say instead of 3, instead of this number, let's say we have 5, 3 or something. So this would be in the same group, and then we'll say we have 4, 8 or something. Okay. So now they'd be in the same group. So, right, so these elements have 2 set bits, these elements have 1 set bit. So basically, we can just keep track of a couple things for our group. We can keep track of the min, the max, and the set bits. So we can start with the first number, and so the min and the max are both going to be 5, and the number of set bits is 2. Then we'll go to the second number, we'll check, is it in the same group? It does have the same number of set bits, so it is in the same group. And then, is the min smaller? Yes, it is, so now our new min will be 3, and our max will still be 5. Then we go to the next number, we say, is this the same number of set bits? No, it's not. So then we're going to take this and turn it into a group. So with a min of 3 and a max of 5. And now we replace this, so min 4, max 4, set bits 1. And then we just move this on. So this is min 4, max 8, set bits 1. And then once we're out of bounds, we'll take whatever we have and make it a group as well. And you're basically just appending to a group array. So this will be 4, 8. And then we can just go through our groups and just check. For every group, this is just linear. Let's compare it to the group after it. And this number, this 5, has to be less than or equal to this number here. And it's not. So in this case, this would be false. So that's the basic idea. It's like the trickier version. The simpler version is bubble. Or you don't even have to know bubble. You just basically have to figure out like a sorting algorithm that swaps elements. And that's basically bubble. I think you should be able to like figure it out on the fly. It's not super hard. So let's take a look at the code. And this is going to be the code with the groups. So essentially, we're going to take every number in num, and we're going to make a 2D array of the number and the number of bits in that number, which is like the set bits, right? And that function's pretty easy. Or just really quickly, that function basically just until the number is 0 and it was 1, and if we get a 1, then add that to the result, and you keep shifting it to the right. So you just keep taking the last bit. If it's a 1, add 1, shift to the right until your number is 0. That's a pretty easy one. I think a bunch of languages have a default function to do this for you as well. So you can look that up. So essentially, we're going to get this 2D array. Then we're going to make the segments array list, which is these segments here. So this is like a segment, so on. We're going to initialize the first segment to be the first element. So the min will be the first element, the max will be the first element, and the bit count will be the first element's number of set bits. Then we're going to go through the rest of it. We're going to get the number, we're going to get the bit count, and we're going to check if it's not equal. That means we have to make a new group. And so we're going to take our current group, add it in, and then make a new group. If it is equal, just update the min and the max and keep going. And finally, at the end, take whatever you have left and update and add that in as well. Then we go through our segments, and we just compare adjacent segments. So like I said, if the max for the previous segment is bigger than the min for the next segment, then this is basically false, otherwise returning true. So as far as time complexity, so to get the number of bits in a number is technically logarithmic, but because these numbers are like 32 bits or something, you can basically say that's O of 1. So yeah, to go through all the numbers and put them into segments is linear time. To compare segments is linear time. So this is going to be n, and then space. So what we did is we took every number and we stored the number and the number of bits. So that's already linear time. Then we also store the number of groups, which could be, or linear space. So like, storing an array of num and bits is linear space, and then storing these groups is linear because every single number can be in its own group. So both linear. Yeah, and then you can run that guy. So yeah, either way, bubble or the other one's fine because the constraints are really small here. So you just like anything works really. If these constraints were 10 to the 5th, then you would have to go with the solution because the bubble would fail. Yeah. So that's just basic things to recognize. Look at the constraints and figure out like what's possible, what's not. And yeah, it's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.